Okay, let's jump right into this. Today, in this explainer, we're exploring how extreme climates reveal the hidden, gritty mechanics of your home's cooling system. We aren't just talking about basic air conditioning here. We are analyzing a masterclass in mechanical endurance. We're going to look at exactly what happens when a vital piece of your home's infrastructure is pushed to its absolute breaking point. And we'll be using the brutal, unforgiving summer heat of Central Texas as our ultimate real-world testing ground.
To break this all down, we're going to hit four main areas today: the Texas heat test, the anatomy of HVAC failures, the $5,000 rule explained, and finally, a look inside professional HVAC service. But before we get into any of the solutions, we have to ask ourselves a pretty fundamental question. What actually destroys an air conditioner in the first place? Is it just old age? Is it poor manufacturing? Or is it a relentless environmental assault? Because as you'll see, Mother Nature plays a much larger, much more destructive role in wearing down these machines than you might think. All right, let's get into part one. The Texas heat test, environment versus machine. Let's look specifically at Pflugerville, Texas. Summer temperatures there routinely blast way past 100 degrees. And we're not talking about a brief, freak heat wave. This specific climate forces air conditioners to run without any relief from May all the way through September. Imagine putting your car in park, pressing the gas pedal all the way to the floor, and just running the engine at redline for 5 months straight. That is the grueling, everyday reality for these cooling systems. They literally never get a chance to cool down themselves, which causes some intense, premature wear on all the vital components. And you know, this climate brilliantly illustrates a massive infrastructure clash. In older, established neighborhoods, homes are running these undersized units that were installed way before modern load calculation standards even existed. So they run constantly, but they never actually cool the house down, which just sends your utility bills straight through the roof. Meanwhile, in all these rapidly expanding new subdivisions, developers are often cutting corners with builder-grade minimum efficiency equipment. It simply can't handle the Texas heat, and it starts failing within just a few years, leaving new homeowners totally shocked by massive repair bills. But get this, the ground itself is actually fighting your AC. Pflugerville sits on expansive clay soil, which basically acts like a giant, destructive sponge. When it rains, it expands. When it bakes in the summer sun, it contracts. This constant shifting literally moves your home's foundation, physically ripping apart the ductwork hidden up in your attic or under your crawl space. Think about that. You could be bleeding 20% to 30% of the air you just paid good money to cool straight into the dirt, long before it ever even reaches your living room. Which brings us to part two, anatomy of HVAC failures. What breaks under pressure? Under conditions this extreme, specific components are always the first to surrender. Constant 100-degree heat just cooks the compressor, which is the literal heart of the system, leading to a total catastrophic failure. Then you've got the capacitors, right? Those are the electrical kickstarters for the motors. Endless on and off cycling burns them out completely, meaning your system won't even start. And as we just talked about, the shifting earth tears open the ductwork. What's even worse is the domino effect here. A weak capacitor forces the compressor to work way harder, eventually destroying them both. This environmental war takes a massive, massive toll. Nationally, an HVAC system will usually last you about 15 to 20 years. But in an extreme climate like Central Texas, that lifespan plummets to just 12 to 15 years. The constant humidity and that grueling heat literally shave half a decade off the life of this equipment. That means homeowners down there are replacing $10,000 systems significantly more often than folks in the rest of the country. So, moving into part three, the $5,000 rule explained. The economics of comfort. Knowing that failure is pretty much inevitable under these intense conditions, we arrive at the ultimate dilemma for any homeowner sweating through a summer heat wave. Do you pay for a temporary Band-Aid fix on a dying machine, or do you bite the bullet and buy a whole new system? Making an emotional choice here, usually out of pure desperation to get cool, can cost you thousands in wasted repairs down the line. To take the emotion and panic right out of that high-stress decision, you need a formula. And it revolves around one simple golden number that you should absolutely memorize right now. If you take away anything at all from this explainer, make sure it is this exact number, $5,000. Okay, here is how the $5,000 rule actually works. You just multiply your system's age by the estimated repair cost. Let's say you have a 12-year-old unit, and the technician quotes you a $500 repair. Well, 12 times 500 is $6,000. Because $6,000 exceeds our golden $5,000 threshold, the math is literally making the decision for you. Replace the system. Repairing it just means you're throwing good money after bad on a machine that's already bleeding your wallet dry through lost energy efficiency. And listen, in the HVAC world, timing is everything. Buying a new system in the off-season from November to March puts all the leverage right in your hands. Contractors have low demand, which means better pricing and really flexible scheduling. But if you wait for a mid-July breakdown, you are entirely at their mercy, pretty much guaranteeing you're going to pay peak emergency pricing. So if your system is showing warning signs, do not wait for the hottest day of the year to make your move. All right, our final section, Part 4. Inside Professional HVAC Service, the gold standard. So, what happens when the professionals actually step in to revive a dead system? Well, top-tier companies rely on a really strict 3-step process to completely eliminate the guesswork. Step 1 is rapid diagnosis. They use precision tools to measure voltage and pressures to find the actual root cause, and they give you an upfront flat-rate price. Step 2 is execution, strictly following manufacturer protocols. There's no trial and error here. And step 3 is confirmation, where they actually run the system through full cycles to verify everything is perfect before they ever back out of your driveway.
Because true professional service is about way more than just turning a wrench, right? It means adhering to highly specific technical standards. Technicians have to hold federal EPA Section 608 certification just to safely handle those refrigerants. But even more importantly for your day-to-day comfort, they use something called ACCA Manual D to correctly size your ductwork, and Manual J load calculations to size the actual AC unit to your home's specific insulation and window layout. It's an exact science. There's a brilliant quote from our source material that proves exactly why these calculations are so critical. It notes that undersized systems never achieve comfort, while oversized equipment short cycles and wastes energy. Guessing the size of your AC unit is just a guaranteed recipe for sky-high utility bills and a totally miserable summer. If a contractor installs a system that's too big, it drops the temperature way too fast without running long enough to actually pull the humidity out of the air. That leaves your living room feeling like a cold, damp cave. No thanks. So armed with the $5,000 rule, an understanding of the massive environmental pressures out there, and knowing what true professional standards actually look like, you've really got to ask yourself, is your home's cooling system truly prepared for the elements? Because the next massive heat wave isn't a matter of if, it's a matter of when. Are you going to be the one holding all the leverage this November, or are you going to be making a desperate, super expensive phone call in July? It might be time to go check your filter, listen to your compressor, and do the math. Thanks so much for joining us on this explainer, and we will see you next time.